Hey guys, it's Dr. Deshavo. I'm here going over acid base with you today, and this is going to be a vocal lecture. We're going to be looking at the PowerPoints. There's not a lot of visuals that I need to show you, so I'm just going to audio tape it right on my computer. So the main thing to keep in mind with acid base is very confusing, okay? There's several things to keep in mind, but the things that we're going to keep in mind is this. So acid base is going to be the mechanisms that will change the pH in our body, okay, the acidity of our body. And if you remember from A&P 1, in order to change the acidity of the body, we have to either increase or decrease the amount of hydrogen ions in the body. Okay, that's pure pH theory. Now, there are other substances in the body that can change our acid base or our pH. Okay, so the main two things that we're going to talk about, there's actually three things, but the two things you could see on this page here are respiratory and metabolic, okay? So two mechanisms or body organs or systems that can change acid base or pH are going to be respiratory, which is obviously going to be the lungs, and metabolic. And quite often metabolic is going to reference the kidneys or the lungs. Okay, so kidneys or lungs. So get it right into your head, metabolic, kidneys or lungs. Okay, so respiratory, the thing to remember with respiratory is that respiratory deals only with carbon dioxide. Okay, it only deals with carbon dioxide. Carbon dioxide is acidic. That is the thing to remember. Carbon dioxide is acidic. So if we retain too much carbon dioxide, we'll become more acidic. If we exhale too much carbon dioxide, we'll become less acidic. Okay, so CO2 is acidic. Now, CO2, when it's traveling through our blood, can actually combine with water to form carbonic acid. It can act somewhat as a buffer, okay, and it can move it through the body as a more, less, I don't want to say dangerous, but less harmful substance. Okay, so CO2 plus water can form carbonic acid. And if you remember your chemistry, which I'm sure you do, you can see by combining H2O with CO2, we get H2CO3. They all add up, right? Okay, and that carbonic acid, as I said, is less acidic in the blood, and it almost sort of buffers it, so it can travel through our blood without creating more acidity in the body. Okay, so treatment if somebody has too high levels of carbon dioxide or the partial pressure of their carbon dioxide in their blood. And what that means is the pressure of that carbon dioxide gas in their blood. If that gets too high, we'll try to decrease that level with a ventilator. Okay, putting somebody on a ventilator. But the main goal with any of these conditions that I might know is to treat the underlying cause. Why is somebody becoming more acidic? Maybe they have, some sort of breathing condition, such as emphysema or COPDs that we talked about in respiratory. Okay, so respiratory. Driving mechanism is high levels of CO2 or low levels of CO2, treatment with a ventilator. Now, metabolic. Metabolic is going to once again deal primarily with the kidneys, but it can also deal with the blood. Okay, so normal metabolism is impaired, acids form. Okay, this can also be due to poor blood supply that's not cleaning out tissues. Lactic acid can build up. Okay, there's multiple causes, but the main mechanism is going to be kidneys. Okay, so treatment's finding the underlying cause again. In the meantime, you can treat if somebody is metabolically acidic. You can treat with bicarbonate, and I'll go into some of those mechanisms in a little bit. Okay, so metabolic, kidneys, blood. Okay, at the bottom they put that's it. I actually copied this from a website. Yeah, that is it basically, but underlying mechanisms are more complicated than that. Okay, but the whole of acid base in 6 sentences. Okay, so pH review, just a little review. So pH is driven by the amount of hydrogen ions. Okay, that is talking purely about the pH scale. Okay, and if you remember, the pH scale was 0 to 14, and the whole pH is measured by the level of hydrogen. Now, I want you to keep in mind that other substances are acidic in the body and also alkalinic or basic. So other things can change our pH, but when we're dealing with purely the pH scale, hydrogen is going to be the main driver of changes in pH. Okay, so a decrease in pH. So if we go below a 7 on that 0 to 14 scale, it means we're becoming more acidic. Okay, so there's an increase in acidity. If we go above a 7, it means that there is a decrease in acidity. We're becoming more basic. Okay, you don't want to go too extreme with either one. You want to keep it right around neutral in our body. 7.35 to 7.45 is our range. Now, metabolic acidosis. Okay, so metabolic, once again, kidneys or blood, substances in the blood. Okay, metabolic acidosis is a pH that is too acidic for the PaCO2. Okay, don't let that blow your mind. Let's just think of it as being we're retaining some sort of acid in the blood, be it that the kidneys can excrete it or we're having some sort of complication with acidity in the blood. Okay, if you remember from diabetes, ketoacidosis is going to be an increase in acidity in the body. Okay, so that would be another example of metabolic acidosis. Okay, so there are multiple causes. The kidneys are a huge cause, but also problems in the blood or conditions that create acidity in the blood can also create this metabolic acidosis. Okay, so buildup of lactic acid, buildup of pyruvic acid. I know those don't sound familiar. Don't let them blow your mind. Once again, ketoacidosis is going to be the main one that we'll talk about in the blood. That's going to be acidity that's built up from people who are diabetic. Okay, so metabolic acidosis is going to be increase in acidity in the body due to a problem with the kidneys or a problem that causes acidity in the blood. Respiratory acidosis is when we retain too much carbon dioxide. Okay, carbon dioxide is acidic. Okay, it is not an acid. It creates acidity in the body. Okay, and when we retain too much CO2, we will become more acidic. Okay, excuse me. So if we can get rid of it through the lungs, we will become more acidic. Okay, so carbonic acid's only formed when combined with water. When we combine CO2, I showed that to you earlier, we'll get carbonic acid that works somewhat as a buffer. So it'll buffer the acidity of CO2, stop up that CO2 and carbonic acid, which is H2CO3. So bear with me, if we combine water, which is H2O, with CO2, we get H2CO3, and that is carbonic acid. So we buffer that CO2, and we create a less acidic version. Okay, carbonic acid is less acidic than CO2, even though it's still an acid. So measuring acidity. So CO2, PCO2 is the partial pressure of carbon dioxide. What that means is that is the pressure that gas exerts in the blood when it's in our blood. Okay, the normal value or amount that we should have in arterial blood is 40 millimeters per mercury. Okay, so acidemia means that the pH is more acidic. It's going to be lower than 7.4 because don't forget that in the human body, normal is 7.35 to 7.45. We're not talking about the 7 on the pH scale, which some of you are thinking, I bet. Excuse me. So acidosis means that somebody is going to be more acidic. Alkalosis means that they're more alkaline, so they're above that 7.4. Now what happens, excuse me, what happens with people in acidosis? So if somebody has what is called respiratory acidosis, that means that they're retaining too much CO2. Okay, so if somebody has respiratory acidosis, they're retaining too much CO2. Okay, the kidneys will try to make up for that. And what they will do is get rid of hydrogen ions. Okay, we just learned in the kidney lecture that the kidneys will balance pH by hydrogen ions as well as bicarbonate ions. So if somebody's too acidic, the kidneys will get rid of hydrogen. Now, I realize it's not getting rid of CO2, but what the body's trying to do is balance the pH of the body. Okay, so Respiratory acidosis will cause the kidneys to compensate by getting rid of hydrogen ions, and they will also retain bicarbonate ions to buffer that acidity. Okay? If we have, this is very unusual, but if we have a respiratory alkalosis, okay, so if somebody is getting rid of too much CO2, they're hyperventilating, they're breathing really deeply, okay, usually that's very transitory. They'll pass out, so the breathing will regulate and they'll be fine. If that were to continue, okay, and they have a respiratory alkalosis, big, heavy, deep breathing, they're getting rid of too much CO2, okay, what'll happen is the kidneys will compensate by getting rid of, you got it, bicarbonate and retaining hydrogen, okay? So we can have either respiratory acidosis or alkalosis, okay? Now, we can also have a metabolic acidosis. So quite often that'll happen either from people who are diabetic, getting acids in their bloods, okay? Or the kidneys retaining too much hydrogen, okay? And what we'll see with with a metabolic acidosis in people who are diabetic, they'll build up acidity in their body, and what they'll do is they'll start breathing deeply to get rid of that CO2, and that'll compensate for that metabolic acidosis, decrease the acidity in the body, and make them closer to the normal pH. Okay? So, that metabolic acidosis is compensated for by that deep breathing. And I'm sure that would happen if you had that kind of damage in the kidneys as well. But quite often we see that deep breathing with people who are diabetic. Okay, so metabolic acidosis can be compensated by respiratory means of getting rid of CO2. Okay, so, and that would be the opposing alkalosis. Don't even think of it that way. That's going to blow your mind. Okay, so you think of it as a compensation, or quite often you'll hear it clinically as a compensatory mechanism. Okay, so patient often has both at the same time. Okay, metabolic acidosis and respiratory compensation or alkalosis. Okay, so if they have a metabolic acidosis, they're acidic, they'll do deep breathing and try to get rid of that CO2. Okay, so one dominates, that's going to be the one that we have some sort of problem with, and the other will partially compensate. So, buffering. So, metabolic acidosis, those metabolic acids, you cannot get rid of them through the lungs. So instead of breathing deeply and getting rid of them, they have to be neutralized or metabolized or excreted through the kidneys. Okay, and that's when we'll start dumping hydrogen. We'll break those acids down, we'll get rid of them through the kidneys. Okay, now we also have a blood buffer system. Okay, so we can deal with acidity by getting rid of carbon dioxide. We can deal with acidity by getting rid of hydrogen through the kidneys. But we can also deal with acidity by this system, which is in the blood, called carbonic acid bicarbonate system. Okay, and there's actually another part to this equation that we spoke about before. On the other side, we have CO2, which can be added to water, which can form carbonic acid. Now, carbonic acid is an acid, but it's very weak. So it's not going to create a lot of acidity in the body. Okay. So if we have too much CO2, we can combine it with water in the body and we can form this weak acid, which is carbonic acid. And basically what carbonic acid is it's going to tie up that acidity of the CO2. Now, carbonic acid can also be transformed, and this is looking at the screen here. Oh, and I think I can actually point to it now. And I can draw. How cool is that? I'm sorry, this is a new system for me. So, here's our CO2. I'm sorry, H2CO3. I got so excited I could draw on this. So H2CO3, you can see we've got 2 hydrogens and 2 oxygens and 1 carbon. So we can actually make H2O, water, and CO2 from this, okay? Right here. Now, so we can push the equation this way and we can create water and carbon dioxide, or we can sort of trap up that water and carbon dioxide and we can make this carbonic acid, which is a very mild or weak acid, which doesn't really change the pH of our body very much, okay? But on the other side, we can also take the hydrogen ions that we'll see in the kidneys or in the bloodstream, okay? We can combine it with this, which is bicarbonate, HCO3. There should be a little negative up here. Oh, negative there. Okay, so hydrogen can combine with HCO3, which is bicarbonate, and form H2CO3. And what we're doing is we're taking that really acidic hydrogen ion and we're combining it with bicarbonate and we're buffering it into a very weak acid, which is carbonic acid, which once again won't change the pH too much. Okay, so carbonic acid bicarbonate system, it's a little bit confusing. So by all means, if you don't understand this, come see me. But basically, carbonic acid, okay, this guy right here is going to be the buffer system. It's part of the buffer system that can either sop up carbon dioxide ions, okay, and make them the body less acidic, or hydrogen ions and make the body less acidic. So it's a very powerful tool. And this is once again found in the, I don't know if I could write with this, blood. Well, I can write with this. This is really cool. All right, so very cool. Great stuff. Looks like I'm bleeding on the paper for you. So that, guys, is acid base. And I know it's really hard. So if you don't get it, please, by all means, let me know, and I'd be happy to go over it with you. Thanks. This is Dr. DeChavo. Talk to you soon.